day 9 of AdventConf 2019. So I already took a look at the exercise, and it's gonna be continuation of the Encode computer. So I'm gonna copy the last code from here to a new module. Okay, close folder. Gonna go new day 9 and open folder day 9. From the description, I know that we will not get the amplifier thing anymore, at least for now. The permutations, so all these go away. And these go away. All of this. We will not have phase setting anymore either, but the rest should be fine. So I'm gonna run fmt and test. Let's check what we got here. So the thing is, we need to implement a new parameter mode, another opcode, the opcode 9. So before doing that, I think I will unify this code that involves parameter mode and instruction addressing. And for that, I will have a new function called access of which will return a mood of E64, something like that. Instead of the value itself, let's return some reference like this. Before that, maybe okay, this is fine. What is going on here? That should be fine. I don't know why it's complaining. Okay, because maybe I need to put it before. Oh, because of borrow problems. So something like that, no? Okay, so at this point we should be able to replace this code by the upper function. And we do this by saying simply on the get, we just do access and the ref. You only need to fix this thing. Right, and the set needs to be address still, and we will do it like this: access equal, and the ref here in front. Yeah, okay, now we have all the important code in one place. Okay, it also at some point will ask us to have kind of a bigger memory, not only the instruction to operate. Where is it? Computer available memory should be much larger. So for that, I'm gonna use a hash map. Collection, sorry. It's in the same model, so I can import it right away. I'm gonna put it here. I'm gonna call it memory. At the beginning it's gonna be like usize because it's the same address type. I'm gonna put it here, memory. So the difference between memory and the instruction is gonna be when it is not an instruction, it's gonna be a memory. So in order to reflect that, I will implement another function called instruction that will take a position, let's say, which is usize, and will return mode e64. So we'll say if position bigger than self instructions len, we'll do something with hashmap. If otherwise, it's gonna return self instruction position like that, and a mode reference to it. This part should be fine. So we're gonna say if self memory contains key position, we return it. Otherwise, or better said, if it doesn't contain, we fill it with 0. Position 0, and then get mode position. Yeah, this is an option, so we expect this to be initialized like that. I don't know what is complaining about. Okay, we need not a reference here. So for now, I will just replace these functions, this indexing by functions. In theory, it should be as easy as that, and I don't need even to put the mode here, but I need the ref here, right? Let's see, it's working still. Yep. Just to be sure, I want to. Okay, I need to use it here too. I want to know that we only index instruction array. The graph here also. We want to use only instruction array indexing here. Yep. There is no other occurrence, so we are fine. Okay, what is complaining about? This should be mode self now. Okay, not a big deal. So I see the test pass. Let's check if I change something. Should not pass. Okay, it's not running. Why is not running? it's not running anymore. I don't know why I have this problem sometimes. Oh. Okay, in the meantime, I'm gonna be implementing the new mode. So it's saying that in relative mode we come from a value called relative base, so we will have to put a relative base over here, which should be kind of a pointer also. It says when the relative base is 0, relative mode parameters and position mode parameters will have the same value. So I think this is a test. We can put it right away. Let's say test let's work with the input 203 base 0 equal 3 or like that. So I want to check that uh, 203 right away with some input. I will take from the first, should be, I will output it 0, 4, 1. The input will be 42. If I'm not wrong, it should be 42 right away, or maybe I need a 99. Yeah. It should be 42 right now. Taking a bit of time to compile this thing. Okay, let's split this in two tests. One should be base 0 input 42 equal 42. And the second one is gonna be the more interesting one. So it failed because it's not implemented. Let's go for it. So okay, I was reading about this and even tried a bit, but it looks like this was kind of confusing, but it's supposed to be the same. And now it works. So I'm gonna put it like that, by the way. So if I compare this to the same thing but with 3, it should give me the same result. Yep. Other than that, I think there are some examples here. Yep. We can implement them. So let's say relative mode sample 1. Should be something like that. We'll copy this. And it says it produces a copy of itself in as after processing. So I'm gonna take the instructions, I'm gonna compare with this, and I need to stringify. Need too small, like that. What do we get? Panic with something wrong. So this is because I don't implement in the new opcode, right? I don't see the new opcode here, but okay, let's do it. So the 9 is, we get by the value of its only parameter, increase or decrease. Okay, so we get this, and then self ptr plus .2, and then we do self relative base plus equal first as usize. Okay, the first sample is working. Let's go for the second one. Second one is saying this thing should output a digital number. Okay, that's interesting to test. So we'll not need a stringify, we will need count digits. And we'll not check the instruction, we'll check the outputs 0. And we will put 16 here. So let's implement that function very fast. So basically let move counter 0, return counter, and then while n bigger than 0, and by 10, and counter plus 1, something like that, no? Yep, done. And this one shall output the large number in the middle. So for this, maybe we need to address the variable size. I don't know. I don't need a function anymore here. I just need to check that we get this. Very fine. It's working. So in theory, this should work already. Let's see that. Of course, I didn't even put the puzzle input. Should be an array of I don't know, E64, SHU. Let's look for that. So how many are there? There are 973. Good. Let's go to the main. And what do we need to calculate actually? is fully functional. The bus program should import. So basically, output single value. Okay. So it's basically computer and but computer in puzzle input to rec with input 1, I think it says here. Yep. Run. We get output 0. Okay. See what we got now. Hello. Okay. This doesn't look like it is the solution. So let's take a better look into this. Like that. Yeah, this is not a single solution. So here is saying the boost program will ask for a single input. Run it in test mode by providing it with the input value 1. We perform serious check. So if it outputs any opcodes, that seems to be functioning incorrectly. So the 203 is working bad. We can try to test for that better. So here we test with the 203 with base 0. Let's test with bigger base 1000. It should just get equal 40 with input 42 equal 42. Let's say. So let's put first the base. How to put the base was the code 9 1000. This should be already not passing. Why is this passing? Okay, because we need to output the 1000 also here. Okay, we don't have that. So I need to take from the 1000, right? But it's not going there. Okay, of course, because we actually didn't do much about the mode 2, we just did the same. Okay. So what if we have the base here? What do we got now? Okay, we got 2 fails. There is an overflow attempt. I want to know where is the overflow. I think we only have 2 or a few pluses. I want to check it's not here. I should not be here because we don't put this address at all. It should not be here either. So to me it looks like our types are too small. So for me, I was thinking use size was E60, like same size as E64, but maybe it's not, or maybe the byte, I don't know. So I'm thinking we can use E64 for all. Maybe that even simplifying the code a bit. like that. So if I do that, yeah, there is some problem here that this should be as A64 and instructions how to solve this. If it's a vector, just put as usize here. Okay, so now it's not overflowing. That's progress. Let me also remove all the castings. In most of them they are useless now. Let's go to the top. Where are the castings? The first one. Okay. Let's go for it. No, that one is needed. Yeah. Okay, so let's go to the test. This is this function, right? Saying that we get 0. What if we get from 0? No. So 3 is using this, yeah, should be fine. So y is not returning what we want. Let's check first the main. Let's see if it's working. It seems like it is working the main. So maybe my test is wrong, but I want to make it right. So we put 1000 here. I want to know what is the memory like at the end. So this I can print it from the run thing. Memory like that. 1000 is 0, and it should not be 0, it should be 42. I don't even think this is correct anymore. So if we put 1000 in the base and we read one input, what is this? Okay, now it passes, but shouldn't be the case. It's like it's not reading the 2 from here. Okay. Let me understand this. Mm-hmm. The mole was again same like this, but with the relative base. Well, I'm not sure anymore. I should store when the memory is getting filled by zeros. That's expected. But what is not expected is that this 42 it is getting into 1, right? Yep. Not in 2, not in 0. It's getting in 1. It's like this is not counting. Yeah, it's counting. So let's do the printing of the relative base here. Mode offset let's print everything. PTR relative base the relative base here is 0. Ah, yep. Understand why. Okay. Should be address immediate. Okay, so now, yeah, now you see the input is in the 1001. Okay, that's interesting. I thought it would be 1000. What if we put the okay, let's this depends on this, no? So let's put 5 is passing. Okay, let's remove all the prints. Okay, now the text the test should be fine. Still we got this number. See if it's correct. That's not the right answer. Oh, I put the square here. Oops. It's a typo, man. Come on. Let me check again. It's a typo. Okay. I don't know what else could we improve. I mean, this is kind of quite ugly. At some point we can use a get first, get second, and have some helper functions like that, but maybe after I finish the exercise today. Can I? Yep. Thank you. You don't have a complete in-code computer. Okay, so basically this is running the program with another input. So easy. Should be much slower, it says. But this is Rust. This is not Python. So maybe we are not as slow as some other people. Let's try. Wow, that was not slow at all. Let's try not to put the squares anymore. Yep, that's it. So it was confusing because of this part. At the beginning I was I already tried this, okay, and at the beginning I was putting this here. It's not the same, but in the description it's not really clear. So that's basically the move you need to do. Nothing else with this is gonna work. So that was all. Thanks for watching, and I don't know, I think I will do the get first, get second, and so on off screen, and this is maybe also a good exercise for the people who want to follow. That's all. Bye bye.